So at the final step is actually running it in Hadoop, and this is just a very short command on how to do that. SSH, DSCIU001, your slash user HTTP current Hadoop stream.jar. So this is familiar. As input, repository movie lens ratings.csv, output ratings. This is still similar. So in the previous example, we run the mapper as the actual executable file. In this case, we are running the mapper as an executable that is not available on the system, and we have to move the file over. So you actually have to tell Hadoop that they need to take this file, mapper.py. And so that file is going to be used as the mapper, and you also need to take this file. Sorry, this should be a reducer, not a mapper. And use that as a reducer. And Recorder Jack asked about how we bring the movie.csv file over. So you also need to tell Hadoop that we are using this file as part of this entire package. So when the job is submitted to Hadoop, it creates a temporary directory, and everything related to that job is placed into that directory. And that's what we do. We put the mapper file, reducer file, and the movie.csv file into that directory. So after you have this command, so remember, change this to reducer01.py. And after you run this command, this is what you should be seeing.
Go back to the command line. I think there's a couple more issues.
Oh, and change your username to your username.
And MapReduce, you've been using the convention of intro dash to dash do, right? Not MapReduce. Not that MapReduce. Right?
Oh, yeah. So the directory should be your intro to Hadoop directory.
However you spell it. What were you saying about the mapper? Which mapper should we be using?
Oh, right here. I just put the wrong name on that. It should be reducer, not mapper.
Oh, fine.
So this is for the Clemson researcher and graduate student. So this cluster is also maintained in the same way Palmetto is maintained. That is, we have about 20 to 30% of the cluster is used as free for all. You can come in and use that. But we also have the remaining is currently being owned by a research group that they contributed to this project. And eventually this cluster, when we grow it, will be the same way as Palmetto. Is we will still have a portion dedicated to everyone to use for free. But if you really want to have extensive usage, then either you or your supervisor need to buy in the same way that you buy in the nodes on Palmetto.
The advantage being you may not have to wait so long for your jobs to execute if you're not waiting in this general queue to get your own owner level access to the remaining resources.
So after you run that, the outcome of the rating file should look something like this. Underscore success, part 000. When you do the cat rating, I'm running this using the reducer that has all the information. So it should coming out like this. Performance, 207 user, 547 is the total sum, and so on. So this is basically an error checking for another way to do error checking. It is also possible to increase the number of reducers. So in this example, you see a single file. path 00 because by default there's only one reducer. In order to do multiple reducer, after the Hadoop streaming node.jar, you just need to put into the -d flag and to tell HDFS that you want to use 4 reducer. So the outcome of that is going to see, you can see this one is 154, this one is smaller in size, and you have 4 smaller files. That's the outcome. The difference between using a single reducer and multiple reducer is not only in terms of performance. Of course, when you have multiple reducer, you are going to have better performance. But also, it's related to your questions. Let's say you want to identify a single movie with the highest average rating across the entire data set. In that case, when you are running 4 reducer, this reducer do not talk to one another, and you ended up with 4 results. Each result is the local maximum for that specific set of keys that specific reducer process. So this is the example code to identify the movie with the highest average rating. I put it max movie and max average. After you run and you calculate the rating average, you just need to put in another if and compare again the max movie and max average. And we set these 2 parameters. Everything else stays relatively the same. Run this Hadoop using 1 and 4 reducer respectively. This is what you get. So for the case where you have a single reducer, a job to kill for 5.0, for reducer you have a job to kill for 10 attitude 5, gentle spirit 5, and so on. So in this case you have 4 possible. For this specific example, it is actually promising because when you use a single reducer and identify the highest movie, you are essentially skipping out on all of the other movies that can potentially have the same value. And only by using multiple reducer that we can start seeing this. This also brings up another issue we're doing with MapReduce and big data. A lot of time you have to rely on your intuitions. When you are dealing with big data, there is absolutely no way that you can look through the entire data set. And anything you do, either it is an educated guess, or basically it's just your feeling that this is right or this is wrong. And in this case, trying to look at numerically, these results are correct. These are the movie with the highest rating. On a bullshit meter, this doesn't make sense. This is a very strange movie with a very recent year, and that doesn't make sense that we think of them as the movie with the highest rating, particularly if you start to look at it from a more business and analytic point of view. You want to identify the movie that has the highest rating, implying that it is highly valued by many users. So this is possible that there are some of the very more like cult movie that has a small subset of users that really like it and really like it enough to go in and just give a 5.0 review. And it has a high average rating. That doesn't mean that it's liked by many users. So this is where you have to start modifying your reducer. So in this case, a way to approach this is to only look at the movie that has at least a certain set of ratings. So for example, let's say I only want to look at movie that has been rated by at least 10,000 users. The question is, do you want to put in that filter on the map side or on the reduce side? Anyone think we can put it in on the map side? Hassan, you are very positive. Why do you think we cannot put it in on the map side?
I guess because if you have multiple maps, how we can count them that they are reaching the 10,000 or not?
Yes. So this is one of the cases where you have to put the check into the reduce size because only in the reduce you get the final aggregated count of all of the keys. So you can put in an additional check on the reduce side that looking back at, you can put in an if after you get to this point around the current rating count, and only proceed with the printing out or the comparison if the current rating count is higher than a certain threshold. So that's how you can start. So with the mapping and reducing, you start to be able to make in some of the internal algorithm for your analytical purposes. So with that, we have 10 minutes to go. I also leave you with two additional challenges to try out at home. So the first one is to write a reducer O3 that basically do what we just did, is to only consider movies that have at least 1,000 ratings totally. And the second case is, let's go and take a look at a different one is to look at the user, identify the user that rates the most movie over time, and identify the genres that this user rates most favorably. So this is the type of questions that when you have massive data set, very difficult to get the answer from. So that's it for today's session. I'll hang around here for additional questions if you have any.